Thanks for watching, and here is a nice interpretation of D'Alembert's formula. Because previously on Paian Battlestar Galactica, we're trying to solve the wave equation, utt is c squared uxx, with initial position phi and initial velocity psi. So utx0 is psi. And what we found is the famous D'Alembert formula, which says that one solution to this equation is u of xt is 1/2 phi of x minus ct plus phi of x plus ct, and then plus 1/2c integral of x minus ct and then x plus ct psi of s. Yes. And the goal in this video is to interpret this, and in particular, seeing what the effect of the initial position is and the effect of the initial velocity. And in order to do that, we will study two extreme cases, one where psi is 0 and the other one where phi is 0. So case 1, assume psi is 0. In other words, we have a wave starting with phi and having 0 initial velocity. In that case, our formula just becomes u of xt is 1/2 phi of x minus ct plus phi of x plus ct, which, if you want, is just 1/2 phi of x minus ct plus 1/2 phi of x plus ct. So what does that mean? Concretely, it means if you start with an initial condition of phi, maybe like this, a spike, so u of x0 is phi of x, then that spike splits into two with this 1/2, one moving to the right with speed c and one moving to the left with speed c. So if you try to simulate this, then you will see that eventually this triangle becomes two smaller triangles like this. So u of xt, one moving to the left at speed c and the other one moving to the right at speed c. And by the way, I invite you to look at the little demo in the links to the video or in the description, where you can see that if you start with this spike, in fact, it will move into two directions. So, in other words, once again, the initial position splits into two, and that's a contribution of the initial position. Now, let's do the initial velocity. So now, case 2, this time assume phi is 0, so we have an initial position. Then in this case, u of xt is 1/2c integral of x minus ct to x plus ct psi of s ds. Now this is a little bit trickier to interpret, so for concreteness, let's give a specific value of psi. So assume psi looks like that. And maybe let's fix a point x. Then we know that initially u looks like that. So u of x0 is 0 because the initial position is 0. And once again, let's try to figure out what happens to this point x. Now, initially, the contribution of psi is 0. So at t equals 0, that integral is 1/2c integral of x minus 0, x plus 0, psi of s ds, which is 0. So in other words, initially, we don't feel anything at x. There's no contribution of psi, but as time goes on, you feel the effect more and more. Because, for example, at t equals 1, we get 1 over 2c integral of x minus c to x plus c psi of s ds, which now is bigger. So this is x plus c, x minus c, which is positive. So initially you don't feel anything, but then at t equals 1, you feel psi more and more. So maybe that would be your u of x comma 1. And in fact, as t becomes even bigger, you feel the effect of psi more and more. So that might be x plus ct, x minus ct, and then u of xt is the same integral, but over the bigger interval. So as t becomes larger, this effect becomes bigger and bigger. So the way I like to interpret this is in terms of an earthquake, because initially you might not feel anything with the earthquake, but the more time goes on, the more you feel the rumble in this case. And this is kind of what psi does. This is at the point x, but then you can do this at every x, and eventually you get something that jiggles more and more. Maybe that might be u of x1, and then as u gets bigger and bigger, you might feel a bigger rumble like this. Which kind of makes sense if you think of it as a string. So if you start with 0 and suddenly you rumble it, then at the beginning you might not feel anything, but later on you feel this more and more. Last but not least, what is D'Alembert's formula? Just a combination of those two. So what is D'Alembert's formula? So general case, what we get is u of xt is 1/2 phi of x minus ct plus phi of x plus ct, and then plus 1 over 2c integral of x minus ct x plus ct psi of s ds. So once again, in this case, we have two contributions. One is the initial position splits into two. So the big triangle splits into two smaller triangles, and for the initial velocity, we have this earthquake effect. Earthquake effect. So that is what is so cool about D'Alembert's formula. It tells us precisely what happens here to the wave. There are once again two contributions, one from the initial position and one from the initial velocity. All right, if you like this and you want to see more math, please make sure to subscribe to my channel. Thank you very much.